So good evening, all of you.
Good evening.
Good evening. Good
Good
evening.
evening, sir.
Good evening. So
Good evening, sir.
good evening. Good evening. In last lecture, we were discussing about KVL and KCL, and I have taken this particular example. It's a two-loop network, and by applying KVL, you can find current through any resistance, and if you know current, you can find voltage across that element. Okay? So because you have two unknowns, so you have to apply KVL in two loops, solve for I1 and I2, you will get the current. Now you can solve same question using current division. So let's see how to apply current division here. Now we have to use current division. So let us draw the circuit again. Same question I will solve using current division. So this is 12 volt. This will be 3 ohm. This is 6 ohm, 7 ohm and 7 ohm. Okay? So let us first find what will be this current. Directly if you have to find current I. And consider this point to be 1 and this point to be 2. So if you want to find current I, you must know equivalent resistance between 1 and 2. So this will give you have, this is 12 volt, this is 1, this point is 2, and what will be the equivalent resistance between 1, 2. Okay? So you have to see which resistance is in series and which is in parallel. Let's calculate. Try to calculate it. So now you can see these two resistance, they are in series. In series, current will be same, and in parallel, voltage will be same. So what is equivalent of these two? This is 14 ohm, and this is in parallel with 6 ohm. So this will be what? 14, then with parallel combination and then series combination. So R equivalent between 1, 2 is given by 3 ohm plus 6 ohm, because these two are in series, then it is in parallel. 14 ohm divided by 6 ohm plus 14 ohm. Okay? So 20 this will be 6 into 14. So this will be what?
18.
3 plus 84 by 20. So what will be equivalent resistance? 60, 140.
7 by 4, sir.
This will be 7 by 4.
Total will be 7 by 4.
3, this is 144 by 20, no? Yes or no?
Yes, sir.
So what will be this value? You should divide.
7.2.
Divided by 5.
Okay, so this is
7.2.
38 by 5.
36, sir.
36 by 5.
36.
36, sir.
Okay. So this is 36 by 5 ohms.
7.2.
Okay, let's write in this form. So now what will be this current I? So current I will be given by 12 volt by 36 by 5 equivalent resistance. So this is 12 into 5 by 36, 5 by 3 ampere. Yes or no? And just see here, what is the current I1? I1 we have calculated 5 by 3. Means you are getting same answer. I'm just focusing on the calculation part, how to apply KVL, KCL, current division rule, answer will be same. Clear? So this current I we have calculated directly by writing I is equal to V by R equivalent between these 2 points. Now this current is I. Let's divide current I in 2 parts. This is I1 and this is, let's say this current is I2. Or let's take this as I1 dash and I2 dash. So now what is current division? I have already discussed the current division rule. Just see, if current I is dividing between 2 parallel resistance, these 2 are parallel resistance. So what will be current I1? I1 is R this resistance into I by R1 plus R2. And what is I2? I2 is this resistance R1 into I by R1 plus R2. So we can directly apply this. So what will be I1 dash? Now see which 2 resistances are parallel. One resistance is this, another resistance is series combination of these two, 6 ohm and 14 ohm. They are in parallel. R1, R2 is what? 14 ohm and 6 ohm. So now find I1 dash. Let's calculate. Try to calculate this value. So when you find I current in this R1, then this will be what? 6 ohm into 5 by 3 ampere divided by 6 ohm plus 14 ohm. And this will be 6 by 20 into 5 by 3. So this is 3 2 times. This is 4 times. So this will be what? Half ampere. And just see same current I2. This current here is I2. Then that will be half ampere. Okay? Current division. It's an application of current division. Then what will be I2 dash? क्या होगा I2 dash? Now this 14 ohm into 5 by 3 ampere divided by 6 ohm plus 14 ohm. And this is what? 14 ohm by 20 ohm into 5 by 3 ampere. And this is 7 by 6 ampere. 7 by 6 ampere. And we have calculated same value. That is current across 6 ohm is what? 7 by 6 ampere. So in this way, by applying KVL as well as by writing the equivalent resistance and then current division, we have calculated these values. Clear? Now take another example. ठीक है? Is it clear? KVL,
Yes, sir.
KCL, current division rule.
Yes,
So
sir.
now I have taken only one voltage source. Now let's see case of more than one voltage source. So take case of two voltage source and try to solve using KVL. This is 12 volt. This is 3 ohm. This is 3 ohm, 6 ohm, 7 ohm, and this will be 6 volt. Let's say this is 6 volt and this is 7 ohm. Now you have to find current through each resistor. Current through each resistor. So what you have to do, when you have more than one source, you don't know the actual direction of current. So initially, you can assume any direction. In KVL, you can assume any direction. If your answer is positive, it means your assumption is right. But if answer is negative, then only thing is magnitude will be same, but you have to reverse the direction. So don't decide what is the actual direction. After calculation, you will get the actual answer. So in this situation, I'm taking, let's say this is minus, plus, and I'm assuming this is the assumed direction of current. This current is I1. I am assuming this current is I2. This polarity is plus minus. This is also plus minus. This is I1 minus I2. Okay? Now again, consider this to be a loop 1 and this to be loop 2. Because you have two unknowns I1 and I2, so you need to apply KVL in two loops. Now apply KVL in loop 1 and 2. Just check. So let's see what will be KVL in loop 1. Let's apply KVL in loop 1 and 2. So in loop 1, you will get 3I1 plus 6 I1 minus I2 minus 12 volt is 0. I'm taking this to be plus, plus, and this is minus. So this is what? This will give you 9I1 minus 6I2 is equal to 12. And in loop 2, you will get 7I2 plus 6 volt minus 6 I1 minus I2 is 0. So this will be what? 6I1 plus minus 13I2. This will be 6. 1 and 2. So solve 1 and 2. Let's solve equation 1 and 2. Solve equation 1 and 2. You will get I1 and I2. Let's solve. solve 1 and 2. So I think if you calculate, I1 will be 40 by 27 ampere. I2 will be 2 by 9 ampere. So this is I1 and I2. Let's say this current is I3. So what will be I3? I3 is I1 minus
sir?
I2.
सर
Hmm.
सर सेकंड इक्वेशन में
minus
minus
12
13
means-
I2 होना चाहिए था
Hmm?
सर इन
सेकंड
लुक
इक्वेशन
टू
में
क्वेश्चन नंबर 2
So this is so this is minus 6 I1 plus 13 I2. So place it on right side. So this becomes what?
right hand side. So
Okay.
in the right hand side
Oh,
minus 6.
this is plus 6, na?
It
So
will
that is
other
remain
side
there, plus
will
6.
become minus 6.
Minus 6 I1. Oh.
This plus 6 go to other side will become negative.
So is it correct?
Yes sir.
भाई सेम तो लिखा हुआ है ना 6 I1
Sir,
minus
plus
13
6
I2 is 6. भाई
Sir.
क्या प्रॉब्लम है इसमें?
सर ये इधर प्लस 6 है ना सर, तो इधर जाएगा तो माइनस 6 में होगा।
अरे यार इसको मैंने ध्यान से देखो ना, इक्वेशन वही लिखा हुआ है। अब या तो मैं इसको ऐसे लिख दूं यहाँ पे।
ओके ओके सर।
भाई ये कौन सा क्वेश्चन हुआ? आप क्या पूछ रहे हो? मतलब ये तो कोई क्वेश्चन नहीं हुआ ना। आप
No,
यहाँ
sir.
इलेक्ट्रॉनिक्स
Sir,
की
इस
क्लास
पे-
कर रहे हो, पोस्ट ग्रेजुएशन ग्रेजुएशन लेवल पे हो, और आप मुझसे कह रहे हो कि 6 इधर लिखे या इधर लिखे। मैं कह रहा हूं कि सही है, उसके बाद भी आप नहीं मान रहे हो। भाई कैलकुलेशन, सिंपल कैलकुलेशन तो आप कर सकते हो ना। मैं लिख दिया, बोल भी रहा हूं, ठीक है, फिर भी आप नहीं रिकॉग्नाइज कर रहे हो। 6 I1 minus 13 I2 is equal to 6. ठीक है? Yes or no?
Yes sir.
Yes, sir.
Now solve it. देखो आपका फोकस कॉन्सेप्ट पे होना चाहिए, ये नहीं कि 2 into 3 क्या होगा, डिवाइड करेंगे तो क्या होगा, मल्टीप्लाई करेंगे क्या होगा। ये क्वेश्चन थोड़ी होना चाहिए कि सॉल्व कैसे करेंगे इसको।
34 by 27, so.
Yes, so you should multiply it by 3. So 6 minus 27, 34 by 27 ampere. Focus on concept, how to apply KVL, what will be polarity. Calculation you have to do. That's why I have just written these two equations and then I have written it. You should verify it whether it is correct or not. If it is not correct, then let me know. Okay? Is it clear? Now see, I1 is positive value, I2 is positive value, I3 you are getting positive value. It means in this particular case, this is the actual direction of current and magnitude is also given. 14 by 20, 40 by 27, 2 by 9, and this will be 34 by 27. So it initially that the direction that you have assumed is the actual direction because your answer is positive. Yes or no? ठीक है? Now see,
Sir,
हाँ बोलो।
sir, equation 1, 3I1 plus 6I2 minus 12V1, sir. It will come 12 only.
No, this is 3I1. This is 9I1, 6 plus 3, 9I1 minus 6I2, and this is equal to 12.
12V, sir. It will come 12 only.
मतलब 12 volt ना, this is 12 volt. Don't write 12 volt here because these are all in the voltage ना. I am writing in KVL in voltage, this equation in volts.
Okay.
Oh, Don't write volt. This equation is in voltage because this is 12 volts. So that's why I have written here volt. So, and I1 you are getting in ampere because this is in ohms. I1 is in ampere. So this much volt. So this unit will be also volt.
Okay, sir. Fine.
Now let's change the direction of, or just change the polarity of these two voltage, or interchange the voltage source. Let's interchange the voltage source and then see what will happen. This I am taking as 6 volt. So this is 3 ohms. This is 6 ohm. Then you have 7 ohms. Now this I am taking as 12 volt. This is 7 ohm. This polarity is plus minus. Now again assume this is the, now I am assuming this to be direction of current. This is the assumed direction. And this is I3. So I3 I am writing as I1 minus I2. Again apply KVL and let's check the polarity. Now consider loop 1 and 2. Let's consider this to be loop 1 and this to be loop. So apply KVL in loop 1 and 2 and find I1 and I2. Let's calculate. Try to calculate this value. So again, you should see in loop 1. So what you will get minus 6. This is in, all are in voltage. So plus 3 into I1 volt plus 6 I1 minus I2 is 0. So can we write it 9 I1 minus 6 I2 is equal to 6? This is one equation. Then you have 7 I2 plus 12 minus 6 I1 minus I2 is 0. So this will give you what? 6 I1 minus 13 I2 is equal to 12. Yes or no? Now solve equation 1 and 2. ठीक है? So what will be I1? Can you find I1 value? Find the I1 value from these two equations. Solve for I1. Yes, what will be value of I1 here? I think I1 is 2 by 27 ampere.
Yes, sir.
And what will be I2?
I get
I2 is minus 8 by 9 ampere. minus 8 by 9. Just solve these two equations, 1 and 2. Now just see, you are getting minus sign. Minus sign means what? This is the assumed direction. So actual direction of current is up. I2 is opposite to the assumed direction. So what we have to do now, you have to show the actual direction of current. So you have to redraw this circuit to show the actual direction. This is 3 ohm.
Sir, I2 is minus 8 by 9 or 8 by 9, sir?
Minus 8 by 9. Please check. If you solve these two equations, I2 will be minus, put I1 is 2 by 27 and then check the value. Just see, 9 into 2 by 27 minus 6 I2 is equal to 6. So minus 6 I2 is what? 6 minus 18 by 27. And this is 6 minus 9, 60 by 9. Is it correct?
Yes, sir. But you also have a negative 6 on the other side, right?
Here you have minus 6 I2. So answer is what? You are getting.
I2 positive, sir.
No, I2 is negative, but here you are getting what? No, this, yes.
54 by 9 होगा.
Yes,
sir.
this is 54 by 9. 54 by 9. But here you have minus 6 I2, no? So what will be I2? क्या होगा?
Minus 12 by 13.
I think 48 by 9 होगा.
48 by 9 होगा ये.
I2 is, okay, just let me check here. 6 volt, 3, this is 6 ohm, this is 7 ohm, and this is 12 volt. So let's check the equation. Minus 6 plus 3 I1 plus 6 I1 minus I2 is 0. So this will give you what? 9 I1 minus 6 I2 is 6 volt. This equation is correct. Then you have 7.
Subtraction is 48 by 9.
Let me check. 7 I2 plus 12 minus 6 I1 minus I2. So what will be this value? This is 6 I1 plus, so this will be minus 13 I2 is 12.
Sir, it's correct. Minus 8 by 9 is the answer.
So now let's check the value, because I have calculated it.
Minus 8 by 9, sir.
Is it correct?
Right, sir. This is correct.
Okay. So please check. You are getting, if I1 is 2 by 27, I2 is minus 8 by 9.
Okay, sir.
Just solve these two equations. So now see. So this is 3 ohm. This will be 6 volt. This will be 12 volt. So I1 is positive. So just see the assumed direction. So that, हाँ बोलो बोलो. क्या कह रहे हो? Please mute yourself. So just see, I1 is positive value. So this will be 2 by 27 ampere. Now actual direction of I2 is opposite, because this is minus sign, but magnitude will be same. Magnitude is 8 by 9 ampere. So what will be this current I3? I3 you will get I1 plus I2. So I3 will be given by 2 by 27 plus 8 by 9. So this is 26 by 27 ampere. Okay? So I3 is 26 by 27 ampere. Is it clear? So it means initially you can assume any direction of current and then apply KVL, solve for I1 and I2. If answer is positive, actual direction is in the assumed direction. But if answer is negative, actual direction is opposite to the assumed direction, but magnitude will remain same. Clear?
Sir, for different loops, can we consider counterclockwise in one loop and the second?
That will not change the result. You can take any direction. In
Okay.
KVL, you can move in any direction. That will not change the result.
Thank you, sir.
Okay. ठीक है?
Yes, sir.
Now we will see. So that is KVL and KCL. Now see, whenever you have more than one source, we can also apply superposition theorem to solve the two or more than two loop networks. So next is, can I take next theorem?
Yes, sir.
Let's see superposition theorem. So in a network, if you have more than one source, then we can use superposition theorem. And according to superposition theorem, you have to find voltage or current due to individual source and other sources turned off. At a time, you have to consider one source and other sources turned off. Then the voltage or current will be simply algebraic sum of voltage of current across that element due to individual sources. So let's see what is the statement of this theorem. In a network consisting of more than one source, the voltage across or current through an element on any element, if you have to find voltage across that element or current through an element in a linear circuit, is the algebraic sum of voltage across or current through that element, voltage across or current through that element due to each independent source acting alone. Other source are turned off. Other sources are turned off. Now we have to see meaning of turned off. Means at a time you have to consider only one source and other sources turned off. Turned off means if you have a voltage source that is replaced by its internal resistance, ideal internal resistance, and if you have a current source that is replaced by its ideal parallel internal resistance. So what do you mean by turned off? Meaning of turned off. It means all the independent sources are replaced by their internal resistance. Are replaced by their internal resistance. Ideal internal resistance or let's see that is we replace a voltage source by 0 volt and a current source by 0 ampere. 0 ampere means infinite resistance and 0 volt means 0 resistance. So turned off means you have to, when you want to turn off a voltage source, turned off means this will be replaced by short circuit condition. And when you have a current source, this will be replaced by open circuit. So 0 ampere. Short circuit you have 0 volt. So that is the meaning of when voltage or current sources are turned off. So at a time you have to consider one source, find the voltage or current due to all independent sources individually acting alone, and then take algebraic sum. So this is the superposition theorem. Clear?
Yes, sir.
Yes, sir. Yes, sir.
So now same example that I have discussed, case of a 2 voltage source. Now we will see how to solve it using superposition theorem. So note it down. Let's let's see how we will apply superposition theorem. Can I take one example based on this?
Yes, sir.
Yes, sir.
Same example that I have discussed. This is given 12 volt, six volt. This is 3 ohm, 6 ohm, and this is 7 ohm. Now you have to find current through each element. If you know current, you know the voltage also, voltage across element also. Let's see, using superposition, you have to find I1, I2, and I3. Okay? So what you have to do, you have to find current through each element due to one independent source acting alone. Other source is turned off. So let's say this is source 1. You have 2 voltage source. We have 2 voltage source. So one acting alone. So what will be equivalent in this case? Now this second source is turned off. So this is short circuited. This will be 12 volt. This is 3 ohm. Now I am taking this current to be I1 dash. This is 7 ohm. This will be I2 dash. Okay? So you have to find current through each element when only source 1 is acting, other source is turned off. So now what will be I1 dash? So for I1 dash, let us first find what is the equivalent resistance between these two. What will be equivalent resistance? So that is given by I1 dash current is given by 12 volt divided by equivalent resistance between these two. So these two are in parallel. And then this is in series. So 3 plus 6 into 7 by 6 plus 7. Calculate this value. So this is 12 by 42. This is 81 into 13. Okay? And this will give you 27. So this is 52 by 27 ampere. Is it correct?
Yes, sir.
Just this is what? Equivalent resistance V by 12 volt by equivalent resistance. Now you should apply current division to write I2 dash and I3 dash. So let's see what will be I2 dash. Current division rule. So I2 dash is 6 into 52 by 27 divided by 6 plus 7. This is 8 by 9 ampere. Yes or no?
Yes, sir.
And what will be I3 dash? Let's check for I3 dash. So I3 dash will be 7 into 52 by 27 by 6 plus 7. So this is 7 by 13, 52 by 27, 28 by 27.
8 by 27.
So this is current through only when only voltage source 1 is acting and other source is turned off. And then voltage source 2 acting alone. So when 2 is acting alone means 1 is turned off. So you will get source 1 is turned off. So this is short circuited. 1 is here, 2 is short circuited. 1 is short circuited. Then you have 3 ohm, 6 ohm. Then you have 7 ohm. This is 3 ohm, 6 ohm, 7 ohm, and this is 6 volt. Now, when you have only one voltage source, you know the actual direction of current. When one voltage source is there, you know the actual direction. It will flow from minus to plus. So this will be the actual direction of current. This is the actual direction of current. Clear? So this current is I1 double dash. This will be I2 double dash. And this will be I3 double dash. Double dash means that is when source 2 is acting alone. And I have shown you the actual direction of current. When you have one source, you know the actual direction of current from minus to plus. So this is the actual direction of current. Now in this situation, what will be current I2 double dash? Can you find I2 double dash? Yes, try to calculate I2 double dash. क्या होगा?
Sir, for I3 dash, same values are multiplied. 52 by 27.
Why? Why same current? Now you have to see equivalent between these 2 points. So this voltage is 6 volt. So 6 volt divided by, now these two are in parallel. So this is 7 plus
2.
6 into 3 by 6 plus 3. So this is 6 by 7 plus 2. 6 by 9 ampere. So that will be what? 2 by 3 ampere. Yes or no? Is it correct?
Yes, sir.
Now this I2 double dash is dividing at this node. So what is I1 double dash. So this is given by 6 ohm into 2 by 3 ampere. Now I am directly applying current division by 3 plus 6 ohm. So this is 6 by 9 into 2 by 3. 4 by 9 ampere. ठीक है? That will be 4 by 9. Now what will be I3 double dash?
2 by 9, sir.
So I3 double dash will be given by 3 ohm,
2 by 9, sir.
2 by 3 by 9. So this will be 2 by 9 ampere. So now see, I have calculated current through each element due to individual source acting alone. So according to superposition, we have to find this current. So this current is algebraic sum of the current due to individual sources. Algebraic sum means you have to see the direction also. So what will be I1? I1 will be given by I1, because I1 dash is 52 by 27. I1 double dash is 4 by 9. Which one is greater? 52 by 27. So this will be I1 dash minus I1 double dash. So 52 by 27 ampere minus 4 by 9. So what will be this value? $40 by 27. And I think we have calculated same value in when we applied KVL also. Just see the previous example. We have already solved this question using KVL. Same question. Just see. We got 40 by 27, 2 by 9 and 34 by 27. Now we are using the superposition. And what is the actual direction of current? Now see, by seeing the current due to individual source, you can see the actual direction also. Because I1 dash is greater than I1 double dash, so actual direction of current is in this direction. So this is the actual direction of current. Okay? Is it clear?
Yes, sir.
Now, what will be I2? I2 is given by I2 dash is 8 by 9 and this is 2 by 3. So which one is greater?
I2 dash.
I2 dash. So this is, and they are in opposite direction. So you have to subtract and you have to see which value is greater. So 8 by 9 ampere minus 2 by 3 ampere. So I2 will be 2 by 9 ampere. Just see. Same value you are getting. Okay? 2 by 9 ampere. And actual direction of I1 is in the direction of I1 dash. Direction of I2 is in the direction of I2 dash. And what about this current I3? Now see, this is I3 dash, this is I3 double dash. They are in the same direction. So I3 will be I3 dash plus I3 double dash. So I3 dash is 28 by 27 plus I3 double dash is 2 by 9 ampere. So multiply with 3, 34 by 27 ampere. 34/27 एम्पियर। ठीक है
सर सर जब ये वाला क्वेश्चन केवीएल से कर रहे थे तो हमने पहले I1 I2 I3 का डायरेक्शन कुछ भी ले लिया था कि बाद में अगर नेगेटिव आएगा तो रिवर्स कर देंगे।
इस समय भी आपको कुछ भी ले लो, कोई भी डायरेक्शन ले लो, बट व्हेन यू आर राइटिंग ड्यू टू इंडिविजुअल सोर्स, फॉर इंडिविजुअल सोर्स यू नो द एक्चुअल डायरेक्शन। अगर कोई एक सोर्स है देन यू नो व्हाट इज द डायरेक्शन ऑफ करंट, तो इसके अकॉर्डिंग फिर आप इसका डायरेक्शन बता सकते हो कि कौन सा मैग्नीट्यूड ज्यादा है। जैसे ये देखो, इन दोनों में कौन सा ज्यादा है, दिस वन इज मोर, सो दैट्स व्हाई एक्चुअल डायरेक्शन ऑफ I1 इज दिस। ठीक है,
पर सर लास्ट में जब हम I1 I2 और I3 कैलकुलेट कर रहे हैं तो हम ज्यादा वैल्यू में से कम माइनस कर रहे हैं, तो ऐसे
हाँ,
तो ये हमेशा ही फिर पॉजिटिव ही आएगा।
नहीं,
तो फिर डायरेक्शन कैसे रिवर्स होगा?
डायरेक्शन मैं कह रहा हूं कि जो डायरेक्शन ज्यादा है, मान लो ये I1 डैश की वैल्यू ज्यादा है, यहां पे देखो, तो I1 की डायरेक्शन क्या होगी, I1 की डायरेक्शन ये वाली डायरेक्शन होगी। अगर ये वैल्यू ज्यादा होता और ये वो कम होता तो उसकी डायरेक्शन इधर हो जाती। फिर ये भाई आपको तो ये क्वेश्चन है ना, इसकी डायरेक्शन पता करनी है, तो I1 की मान लो डायरेक्शन नहीं दिया हुआ है, तो आप इन दोनों को देखोगे, अगर ये ज्यादा है तो ये वाली डायरेक्शन होगी, अगर ये ज्यादा है तो ये वाली डायरेक्शन होगी। बाकी तो मैग्नीट्यूड चाहे मॉड लेके कर लो, दोनों का डिफरेंस ही चाहिए।
हाँ ओके सर, आ गया समझ।
ठीक है,
ओके थैंक यू।
ओके, सो दैट इज द सुपरपोजिशन प्रिंसिपल। क्लियर? देखो अभी मैं आपको जस्ट केवीएल केसीएल थ्योरम्स ये आपको अप्लाई करना सिखा रहा हूं। अगर एग्जाम में ऐसा कोई जरूरी नहीं है कि आप सुपरपोजिशन से ही करो, आप केवीएल केसीएल कर लो, बट पहले मेथड तो पता होना चाहिए ना। अभी हम जस्ट डिफरेंट थ्योरम कॉन्सेप्ट डिस्कस करके कैलकुलेशन सीख रहे हैं। Is it clear? Any doubt in superposition theorem?
No, sir.
Is it clear to everyone?
Yes, sir.
Yes, sir.
Now see, take one more example. एक और एग्जाम्पल करते हैं, और now you should try. Now you should try. This will be, consider you have a one voltage source. This is 8 ohms. Then you have 4 ohms. And then this is the current source having 3 ampere of current. And let us find what will be voltage across. Let's find this voltage. Voltage across 4 ohm resistance. What will be voltage across 4 ohm resistance? Can you find voltage across 4 ohm resistance? One is voltage source, another is current source. So what you will do, let's say this is source 1 and this is source 2. So you will find one acting alone, one acting alone, and other source will be turned off. So this is 6 volt. This is 8 ohm. This will be open circuited. This is 8 ohm. This is 4 ohm. And let's see, this voltage is what? This will be plus minus V1. Yes or no? This will be the actual polarity. When this is open circuited, current will flow like this. So this will be the polarity of voltage. And what will be V1? V1 is according to voltage division rule. So that will, you will get 4 ohm by 4 ohm plus 8 ohm into 6 volt. So this will give you 2 volt. Is it clear? This is for 2 volts. Yes or no? This is volts. Okay? This V, you should call it as V dash. Instead of V, let's call it as V dash you have to find. Because here I'm taking this as 6 volt. Now, source 2 acting alone. Two acting alone. So one will be short circuited. This will be short circuited. This is 8 ohm. And this current will be 2 ampere. Now this is the direction of current. Okay? This is plus minus. So this will be 3 ampere. Now this, if you take this current to be, let's say I1 and this is I2. So you have to find current I2 and then this will be the polarity of voltage. This will be also positive. So what will be I2? This is 4 ohms. So you will get 8 by 8 plus 4.
और current source 3 ohm sir 3 ampere का नहीं है
3
2
ampere.
ampere की
3 ampere. This is given as 3 ampere. Okay? So this will be what? Current division. So 8 by 12 into 3. This will be what? 2 ampere of current. So what will be V2? V2 voltage will be I2 into 4. So this is 8 volts. Now this voltage will be what? Because they are in same polarity. So when you have to take their algebraic sum, this is V1 plus V2. So this is 2 plus 8 volts. So this will be 10 volts. Clear? Is it clear?
Yes, sir.
Yes, sir.
So whenever you have more than one source, you can use superposition theorem to find the current through or voltage across any element. Clear?
इसमें जो नॉन एक्टिंग होगा ना तो
This is sec 2 is acting alone. So this source is turned off. It's a voltage source. That's why it is short circuited. In this case, this is turned off. Current source is open circuited.
okay sir, thank you.
ठीक है? Now we will see another theorem. That is Thevenin's theorem. Can I take next theorem?
Yes, sir.
Chalo. Now let's see what is the Thevenin's theorem. So let's take a two terminal networks. I'm considering a two terminal network. And let's say this is some load resistance. This is R1, this is R2, and this is R3. And this is some voltage V. Now consider this to be 0.1 and this to be 0.2. Now we can replace this two terminal network by an equivalent circuit. And what is the equivalent circuit? We have to consider a voltage source VTH. This is called as Thevenin's voltage. And there is a series resistance RTH. This is 1 and this is 2. So this is the equivalent. This two terminal network can be replaced by its equivalent circuit where there is a voltage source VTH and there is a series resistance RTH across terminal 1 and 2. And then you should connect this load. So if you have to find load current IL here, just find VTH and RTH. And then you will get IL. This current through RL is given by VTH by RTH plus RL. So VTH is Thevenin's voltage. What is VTH? VTH is Thevenin's voltage, and this is called as open circuit voltage. This is the open circuit voltage. Open circuit voltage. What do you mean by open circuit voltage? Across terminal 1, 2, you have to remove the load and measure the voltage. That is open circuit voltage or VTH. So this is V, this is R1, this is R2, this point is 1 and this is 2, R1, R2 and R3. And this is the open circuit voltage. This is open circuit voltage. That is the meaning of open circuit voltage. Okay? If you have to find current through this resistor, so that is the two terminal. Two terminal may be any point. You can have this point also, 3 and 4. So you have to decide what are the two terminals across which you want to write the equivalent circuit. So I'm writing across 1, 2. So across 1, 2, this will be open circuit. If you are considering 3, 4, then you have to remove R1 to write the open circuit voltage. Yes or no? So what will be VTH? Just see in this circuit, because this is open circuit path, so current will flow in this part only. Let's say that current is I, so this is I into R2, and that will be given by VR2 by R1 plus R2. This is the Thevenin's voltage or open circuit voltage. So VTH value is, you can calculate it as VR2 by R1 plus R2. ठीक है?
Yes, sir.
Is it clear?
Yes, sir.
सर
And
एक
now-
बार सर एक बार रिपीट करोगे आप?
If you have any two terminal network, for example, this is, let's say, point 1 and point 2, and there is a network consisting of two terminal network, and it's a linear circuit consisting of voltage and resistance. So what will happen? You should replace this two terminal network by a equivalent network, single loop network, in which you have to consider a new voltage source and there is a series resistance. So this is the Thevenin's equivalent of any two loop network. Any two terminal network can be replaced by its Thevenin's equivalent, VTH, RTH in series across 1, 2. ठीक है?
When the two loops, 2 points are exist.
Exist means, yes, of course, circuit is given.
Then the voltage is VR2 divided by VR1 plus R2. 2
No,
points
so
are exist.
no. Then you have to find this voltage. What is VTH? How you will define VTH? VTH is, because you have written across 1, 2 this equivalent. So just remove the load resistance, whatever be the resistance across 1, 2, remove it. And then measure the voltage across terminal 1 and 2. That is the VTH, open circuit voltage. I am defining what is VTH. VTH is open circuit voltage across these two terminals. ठीक है?
Okay.
It's a theorem. So according to this theorem, this is the equivalent. What is VTH? And I'm defining VTH. And then you have to calculate this. What will be VTH? So in this circuit, because this is open circuited, so no current will pass through. Current will pass through here. So what will be dropped? VTH is simply I into R2. I is V by R1 plus R2. So this will be VTH. ठीक है? Yes or no?
Yes, sir.
Now what is RTH? RTH is the Thevenin's resistance. This is the equivalent resistance at the terminal. Equivalent resistance at the terminals when the independent sources are turned off. When the independent sources are turned off. You know the meaning of turned off. Voltage source is replaced by short circuit and current source is replaced by open circuit. So now for RTH, just see, this voltage source is turned off, short circuited. This resistance is R1. This resistance is R2. And this resistance is R3. This is 0.1 and this is 0.2. Now you should find RTH between these 2 points. This is RTH. ठीक है? By definition, this is RTH. Now see, RTH will be what? These two are in parallel, that is in series with R3. So you will get R3 plus R1 R2 by R1 plus R2. This will be RTH. So once you know VTH and RTH, you will get IL is simply VTH by RTH plus RL, because it's easy to write the current when you have a single loop network. So if you have two or more than two loop network, you can convert into single loop using Thevenin's theorem, and then you should write the current. Is it clear?
Yes, sir.
Can you apply Thevenin's theorem for this particular value of current I1? Can you apply? Let's see. Let's apply Thevenin's theorem for current I1. Means now two terminals are 3 and 4. So what will be Thevenin's equivalent circuit? Write down. Now I have to find I1 here. Now for I1, now you have a new voltage source, VTH dash, and this is RTH dash. This terminal is 3 and this terminal is 4. And now you should connect here R1. And this current will be I1. So I1 will be now given by VTH dash by RTH dash plus R1. Yes or no?
Yes, sir.
But you have to define what is VTH dash and RTH dash. This is the Thevenin's equivalent across terminals 3 and 4. So what will be VTH dash? Open circuit voltage. So by definition, now this is 0.3 and this is 0.4. R2, R3, RL. And let's say this voltage is VTH dash. This is the open circuit voltage by definition, because you have to see open circuit voltage across terminal 3 and 4. Yes or no?
Yes, sir.
Can you find this VTH dash? What will be this value? In this circuit, what will be VTH dash? Yes, anyone?
Will be V only.
V only. Why? Because this will be 0. No current will be flowing because this is open circuited. Then apply KVL, you will get the value. Apply KVL in this loop. So minus V plus VTH dash plus 0 is equal to 0. So VTH dash is, whenever you have to find voltage, apply KVL in any loop. So it means this voltage is V. Now what is RTH dash? So it's a matter of calculation of VTH and RTH. So short the voltage source. This is 3. This is 4. R2, R3, RL. And this will be RTH dash, equivalent resistance between these 2 points. So if you see equivalent, now these two are in series. So you will get R3 plus RL, and that is parallel combination with R2. And once you know VTH and RTH, you will get the current. Is it clear?
Yes, sir.
So any doubt in Thevenin's theorem? What is VTH? What is RTH? And what is the Thevenin's equivalent?
सर ये जो VTH है इसमें हमने KVL ही लगाना है ना, मतलब
भाई इलेक्ट्रॉनिक्स में कहीं भी वोल्टेज पता करना है केवीएल ही लगाना है, ठीक है?
ओके सर।
ये तो मैं आपको डिफरेंट मेथड्स बता रहा हूं, सर्किट तो आप केवीएल केसीएल से ही सॉल्व कर लोगे, है कि नहीं?
यस सर।
But if in exam they have specifically asked you what is VTH and RTH, then you should know what is this theorem. ठीक है?
Yes, sir.
Is it clear? So we talked about KVL, KCL, superposition theorem, and I have just introduced the Thevenin's theorem also. So let's solve the same question that I have discussed with two loop, two voltage source, 12 volt and 6 volt. Same question you have to solve with using the Thevenin's theorem. So whatever question till now we have discussed using KVL, KCL and superposition, you can solve it using the Thevenin's also, just to verify whether you are getting the correct result or not. Okay? So you should try all those questions using two loop network using Thevenin's theorem.
In the last example for Thevenin's theorem, for RTH dash R2 plus R3 plus RL parallel to R2.
R3 plus RL in series, R3 RL in series
resistance,
and then that is parallel with R2.
Okay, sir.
Just see this point now. You have to see what is the point between which you have to find the equivalent resistance. So if you are considering these 2 points, one is R2, another resistance is R3 plus RL, and they are parallel. Okay? Clear?
Okay, sir.
So in next lecture, I will take some example on this, and then we will take the Norton's theorem and other theorem also. Okay? Any doubt in today's lecture? Is it clear to everyone?
Yes, sir.
ठीक है फिर? So try to solve all those questions using Thevenin's theorem. In next lecture, we will take some more examples. ठीक है?
Yes, sir.
Thank you. Okay, thank you. Thank you everyone.
Thank you, sir.
स्क्रीनशॉट ले थोड़ा स्लाइड का,
कौन सा स्लाइड?
लास्ट स्लाइड से,
फर्स्ट स्लाइड।
लास्ट से लास्ट,
अरे
लास्ट
लास्ट स्लाइड ही तो चल रहा है।
थैंक यू सर।
Okay, thank you.